So here's this question. Here are the first 5 terms of a quadratic sequence: 4, 13, 26, 43, and 64. Find in terms of n the n term for this sequence. So we already know that this is a quadratic sequence. And so with that, we begin. So the sequence are 4, 13, 26, 43, and 64. Now we're going to find the differences, okay? And definitely this is going to be 9. The next difference, this would be 13. The second difference, this is going to be 17. And the last difference, this would be 21. Now, of course, you know that this is the first differences. And now we go to the next difference. Again, we do the second difference. And the number here definitely will have to be 4. Again, the difference is 4. Again, the difference is 4. Now, if you look at the second, this is the second difference here. Now, if you look at the numbers in the second differences, you will notice something. They are all 4, 4, 4. And that is the kind of stuff that makes a quadratic sequence. So what you do is you're going to half this 4, 4, 4, and that will give you 2n squared. Okay, 2n squared. Now keep this because you're going to use it next. Again, you would like to write the same sequences again, which is here 4, 13, 26, 43, and maybe 64. And then of course you want to work out the 2n squared here. Yeah. Now we're going to fill in the sequence with this 2n squared. And the first term is 1. 1 squared is 1 times 2. That will be 2. The second term, 2 squared is 4, and 4 times 2, 8. The third term, 3 squared is 9, and 9 times 2 is 18. The fourth term, 4 squared is 16, and 16 times 2 is 32. And the next term, the fifth term here, 5 squared is 25 times 2. This definitely will be 50. So what we're going to do next here, we are going to subtract the numbers, okay, and figure out what number will go underneath, because you're going to subtract 4 take away 2, that will be 2. 13 take away 8, that will be 5. 26 take away 18, that will be 8. And then 43 take away 32, that will be 11. And 64 take away 50, that will be 14. Now if you look at these numbers here, what type of sequence do you got here? Well, it looks like a simple linear sequence, okay, a simple linear sequence. So we want to get the linear sequence for this, and the linear sequence for this, because they go up 3 each time here in the here, so that's going to be 3n, and of course take away 3 here, that's going to be minus 1. Now this number here is the n term for the linear sequence. So now that you know the linear sequence, the n term for the linear sequence, and also the n term for the n quadratic sequence, all you need to do is to add up these two numbers, and they will give you the n term So what you just do, you add up this and this, and if you try to add them, you're gonna have 2n squared plus 3n minus 1. This number is the n term for this sequence. Okay, all right, for these sequences, here are the first 5 terms of a quadratic sequence: 2, 9, 8, 29, and 42. The final terms for the n term for the sequence. Now what you want to do is, first of all, write out the numbers out. It's 2, 9, 18, 29, and 42. Okay, and you really want to work out the sequences, the increase, the first differences. This is 7, and this is 9, and this is 11, and definitely this is 13. Now this is the first difference, and then you go for the second difference, and definitely this is 2, 2, and 2. Now of course, if you look at the second difference, the numbers are all the same. Now that is expected for every quadratic sequence that you do. The second difference has to be the same number. You could have 2, 2, 2 here, or you could have 4, 4, 4, 4 here, you could have 6, 6, 6 here, you could have 8, 8, 8 here. So the second difference is the numbers in the second difference have to be the same. So to find the n term first for this part here, you have to halve this 2, and that will be 1, and that will become 1n squared. Now this number is so very important for you, so you're going to keep it down. Again, we'll repeat the same sequence again here, which is 2, 9, 18, 29, and 42. And we're going to use this n squared here and create another sequence. Okay, so we definitely going to have here 1 squared is 1, 2 squared is 4, 3 squared here is 9, 4 squared here I think 16, and 5 squared here will be 25. Alright, so now we're going to subtract the numbers. Now in trying to subtract the numbers, we're going to subtract down. 2 minus 1 is 1, 9 minus 4, I think that would be 5, 18 take away 9, that will be 9, and 29 take away 16, that will be 13, and then 42 take away 25, that will be 17. Now if you take a look at this sequence right on the bottom here, you can easily tell that this is a linear sequence because they go up by 4 each time. And so we need to work out the n term for this linear sequence, and the n term here, because it goes up by 4 each times, so definitely the n here will go with 4n, and the next number that comes before 1, okay, will be 1 minus 4, definitely going to be minus 3. Okay, so now we have two parts, the n square, which is the for the quadratic, and this is the linear. So all you needed to do now is to add up 2 of the n terms, and then if you do that, that will give you n squared plus 4n take away 3, and this is the n term. And I hope you really enjoyed it. Okay, that's good. Thank you so much. Appreciate it. Okay, bye bye. Okay, right here now we have the first 5 terms of a quadratic sequence: 7, 18, 35, 58, and then 87. Find in terms of n the n term for this sequence. Alright, so to begin, first we need to write out the n term, which is 7, 18, 35, 58, and 87. Now what we need to work out is the first difference, which is definitely going to be 11. Here will be 17, and here will be 23, and definitely here will be 29. This is the first difference, and then we go for the second difference, will definitely be 6, and then here again will be 6, and again you see that that's 6. So you can see a pattern that the second difference always have to be the same number. Okay, they have to be the same number. And of course, if you look at this question, the same number here is 6. So definitely to do the n term, first of all, you have the 6, and that will be 3. And so that would suggest that this definitely going to start with 3n squared. All right. Now this is very important. Note that, because we're going to form a sequence with this 3n squared. Again, we begin with the same number here: 7, 18, 35, 58, and then I think 87. And we're going to form an n squared, a sequence with this 3n squared. Okay. Here is 3n squared. We're going to form a sequence with it. The first term is 1 squared is 1 times 3. That's in 3. The second term is 4. 4 times 3, 12. The third term is 3 squared is 9. And 9 times 3 is 27. And the fourth term is 4 squared 16. And 16 times 3 is 48. And the fifth term is 25 times 3. You get 75. Alright, so what we do here, we will look out for the differences. We're going to subtract the numbers. Okay, we do 7 take away 3, that will be 4, and 18 take away 12, 6, and 35 take away 27, that's 8, and 58 take away 48, 10, and 87 take away 75 will be 12. Okay, so now if you take a look at this sequence, you can immediately notice that this is a linear sequence. Okay, because the number goes up by the same number each time. Okay, all right. So what I think you need to do, we need to figure out what is the n term for this linear sequence. And because the number goes up by 2, okay, so that's begin with 2n. And what number comes before 4 if you were to continue the sequence? Okay, see if you're going backward, and that will be 4 minus 2, and that will be 2. Now this is the n term for this linear sequence. And so to get your final answer, you need to add the 3n squared here and also add it to 2n plus 2. And when you do add it, you get 3n squared plus 2n plus 2. This is the n term for the sequence. All right, and I'm happy that you found it very helpful. Okay, thank you so much. Okay. All right.